first impressions, I encountered some issues in right side flight that I wanted to address. Since that video, I have, of course, turned my cockpit back to English. I am flying again without the autopilot, and we are just about ready to go here on the runway. So, my plan is basically to show what left side flight looks like, and then compare that to what I see in right side flight. Now, just some basics and things that I may expect to see in left side flight. For a helicopter like the Mi-24, the rotor that spins clockwise when viewed from above, flying to the left, in a perfect left side flight condition, puts the tail rotor in a climb condition, which means you require more power from the tail rotor. But it's a nice, clean configuration. You shouldn't expect any kind of weirdness, and indeed that is what we see in the simulation. In right side flight, going the other way, you're putting the tail rotor in a descent condition, and you could potentially enter a vortex ring state. And I'm seeing some issues there with the flight model. However, those issues don't necessarily, or are not necessarily consistent with a tail rotor entering VRS. It's I think something else is weird. So this video isn't so much to speculate exactly what's happening, but just to show the issues, and that there might be something that needs to be fixed or corrected, or changed slightly to be a little bit more realistic. So anyway, I'm going to pull us up into a hover here, and we'll go ahead and get started. So I'm using the trimmer this time. I didn't use the trimmer in my last video just because I wanted to kind of feel what the controls were doing. But that's not really the purpose of this video. I'm mostly concerned about the pedals. So I will be trimming my cyclic. So I'm going to bring us backwards here, just so we have the runway in view. We're going to use that kind of as a reference for our side flight. There aren't any obstacles this side of the airport, so we're going to be using that. I'm also going to keep my gear deployed just because we are kind of operating slow, and there's no need to retract it. So I think that's probably pretty good right about there. Okay, I'm going to start by flying to the left. Like I said, flying to the left puts the aircraft in, or the tail rotor, excuse me, in a climb condition, which is good. What we should expect to see is, as the side flight increases, we should have to put in more and more right pedal. And this is because the aircraft is going to want to weather vane into the wind, and that's for two reasons. One, air is hitting the vertical tail, and that's going to want to swing the aircraft around to face the direction of travel. Additionally, the tail rotor, because it's entering a climb condition, the power required is going to increase, and the inflow, I should say, actually, is going to increase into the rotor. That's going to decrease the angle of attack of the blades. That's going to decrease the thrust of the rotor, and therefore, spin us in the pro-torque direction, which in right side flight, or excuse me, in left side flight, is going to be nose left. So obviously, to increase the thrust of the tail rotor, we have to put in right pedal, and that's what we should expect. And indeed, that is what we'll see. So I'm going to go ahead and put us in left side flight. forward flight, but as far as the rotor is concerned, it's, you know, it's edgewise flight, so it's becoming, you know, the thrust is increasing. I don't need as much power. So, but as you can see, I'm having to put in more and more right pedal, and that's good. And at some point, I'm going to be flying fast enough to the point where I just can't put any more pedal in. So I'm just slowly increasing the amount of lateral cyclic that I have to put in. And eventually, yeah, I just can't put in enough. And the aircraft will weather vane into the wind. If I center my pedals now, see the aircraft weather vanes into the wind, into the direction of travel. And, you know, everything is as we would expect. Okay, I'm going to reset here, and we're going to try flying to the right this time. Now, flying to the right is tricky simply because we don't have the visibility. The visibility is not as great. I should say the field of view is not as good. But it's not going to be a big issue because we're going to be facing forward, you know, most of the time, and we know that everything's pretty much clear. So I should mention that I have to start by holding right pedal anyway because we're in a hover, and that's just where the trim position of the pedals is in a hover at this gross weight. So we'll go ahead and start, and immediately, I mean, I'm not even, I haven't picked up hardly any speed, but I'm already having to put in right pedal. You see the nose start to come left already, so that's weird. Let me reset, and I'll try to do that a little bit more smoothly. Okay, I'd say we're pretty well established in a hover here. Try to keep us pointed in the same direction the entire time. We're going to do this very slowly. So the nose is, you can see the nose kind of diverged a little bit there. And I have to put in a lot of right pedal to keep us facing the direction we're going. Increase speed, and the right pedal kind of stays where it needs to be. You know, kind of. This just feels weird because I'm pushing both the stick and the pedal in the same direction for side flight, and that's just not what you do. Feel like I have a little less control, but yeah, and that's more pedal than I have. Now, interestingly, that time it aligned with my direction of travel. Sometimes it doesn't do that, and I'm going to see if I can show that. So I'm entering right side flight, already having to put in right pedal. release the pedal, I turn this way, which doesn't make any sense. So, what do I think is happening? I think what they're trying to do is they're trying to simulate tail rotor, you know, what I alluded to earlier, tail rotor VRS, and loss of tail rotor effectiveness, or what's commonly referred to as LTE, loss of tail rotor effectiveness. I think it's happening way too easily. I think it's entering the vortex ring state really too easily. And part of the reason for that is that, you know, the tail rotor on the Mi-24 rotates such that it's the forward blade, the blade that's closest to the rotor, to the main rotor, is rotating up, and the top blade is rotating rearwards. And that is an optimal rotation direction. The Huey actually doesn't do that, but the Mi-24 does that, and I would say most more modern helicopters use that orientation because it's beneficial, and the reason isn't quite well understood, but it has to do with some beneficial interaction between the main rotor wake and the tail rotor, and it helps to prevent tail rotor VRS. And I don't think it should be entering it quite that easily. Additionally, the induced velocity of the tail rotor is higher than the induced velocity of the main rotor, so I would expect you know, it to be a little bit more resistant to entering VRS than the main rotor. I think helicopters enter VRS a little too easily in DCS anyway, just in general, but yeah, so, and the fact that it spins the other way, you know, as you release the pedals and it spins the other way, it's like there's no effect from the vertical tail, which is a little bit more robust and a little larger in the Mi-24 than it certainly is in the Mi-8. So, in any case, I think that's worth taking a look at. And you know, I don't expect the developers to share, you know, their code or exactly how it's working and everything. Unfortunately, that's not the world we live in, that they can do that. But if there are any devs watching, you know, I would just encourage them just to look at it, see if it's happening a little too easily. Maybe talk to some pilots, you know, see if that's something that has actually occurred, and then maybe just let the community know in general, you know, what are you trying to simulate here? You know, why is it happening? And just kind of maybe some reassurances to let us know that, yeah, this is, you know, this is proper or intended behavior. And if it's not proper and intended behavior, then, you know, please fix it, because, you know, this is annoying. You know, I don't want to be annoyed by something that is, of course, not the correct behavior of the aircraft. As a point of comparison, I wanted to show what happens in the Mi-8. Now, the Mi-8 is an older aircraft. It is, I think it came out in 2013 or something, so it's going to be using an earlier version of the flight modeling techniques used by Dynamics, or at the time, Belson-Tech. I'm actually not sure how to turn the autopilot off without resetting the governor, but it's not going to make a huge difference. I just kind of wanted to use this as a point of comparison. You know, considering the aircraft are relatively similar in terms of their dynamic systems and rotors and stuff like that. So I'm going to go ahead and take off here. And, you know, coming back to the Mi-8 after flying the Mi-24, it's a lot easier, I think. I wasn't great in the Mi-8 before, but I've flown the Mi-24 a bit. Yeah, it's not that bad. Actually, I find the Mi-8 to be a little easier to fly than the Mi-24. Part of that could be the fact that I have the autopilot on right now. Alright, so I'm going to line up here. Wait for him to shut up. Okay, and then we're just going to do side flight to the left and just take a look at what the pedals are doing. And obviously, side flight to the left, I'm going to have to put in right pedal. That's what we would expect. And I can't put in any more. That's the limit, and I'm already, you know, weather vaning into the wind. Release the pedal. And we weather vane right into the wind. So I'm going to go ahead and set us up at the other end of the runway, facing the same way. And we'll fly to the right. Now, I believe this aircraft is quite light. This is the free flight, the default free flight Caucasus mission. And I think we have very low fuel. To the point where sometimes I fly this mission and I'll run out of fuel. Okay, we're a little higher than before. Try to see if we can bring us down a little bit without getting ourselves into the arcs. Side flight. And as a reminder, we are putting the tail rotor in a descent condition. Try to keep the side flight as purely right as possible. Try not to climb. And I'm having to, you know, reduce the pedal and sneak in some left pedal here. Side flight is increasing. And I apologize that I'm not doing this at the same altitude, or the same distance away from the runway, but I think the point is made. You know, the pedal is held pretty well left if you look at the control indicator. And if I center the pedals, we align with the flight path, as would be expected. So, I want to emphasize again that the Mi-8 is using, you know, what is most likely an older, you know, version of their, you know, flight control or flight modeling software, and they're, you know, almost certainly not modeling, you know, the inflow dynamics of the tail rotor in the same way that they are in the main rotor. And I suspect, again, that the Mi-24 is trying to simulate that. I just don't think they're doing a particularly great job. So, you know, I'm not trying to demonstrate what is necessarily correct here in the Mi-8, just, you know, what, you know, the other aircraft do, and that there's an inconsistency. That's all. And I'd just like to get some clarification, you know, what all is happening here, and you know, what they're trying to do, and if it's, trying to figure out if it's realistic or if we can expect some corrections or fixes in the future. I find landing in the Mi-8 to be easier because I have that nice big window that I can use to better judge where I am. anyway, that's just about it from me. Hopefully this this video was useful to somebody. You know, and you know, maybe it will be useful for potentially correcting an issue. And again, I don't want to emphasize that there. You know, I want to emphasize that there isn't necessarily an issue, just that there very likely could be. That's all. Alrighty, that's about it from me. Take care, and happy flying. Bye.